Alright, pretend that you're studying probability. You toss some dice, and you know that you have a probability of 1 over 6 that the number on top of the dice is 2. Or you can also say that there's a chance of 5 over 6 that it's not going to be number 2. So the probability that x equals 2 is 1 over 6, and its complement is 5 over 6. What about graphs? Do they have complements? The answer to your question is yes. Consider that we have 4 nodes, A, B, C, and D. All the possible existing edges between those nodes are AB, AC, AD, BC, BD, and CD. Assume that a graph G is a cycle between A, B, C, and D, as you see on your screen. The complement of this graph will be all the possible edges that are not in G. So the complement of graph G has edges AD and BC. According to the definition, the complement of a simple graph G is another simple graph with the same vertex set, V of G, but with edges that are not on the edge set of graph G. Let me show a couple more examples. Consider that graph G has 4 vertices, A, B, C, and D, and has edges AB, AC, BC, and BD. Node A is linked to B and C, but not with D. So edge AD is not present in graph G. Node B is connected to all the nodes. Node C is connected to A and C, but not with D. Edge CD is absent in this graph. The complement of G is the graph with 4 vertices, A, B, C, and D, and 2 edges, AD and CD. Notice that the vertex set is always the same. Let's check another example. Assume that graph G has 3 vertices, A, B, and C. There are 3 edges, AB, AC, and BC. This graph has all the possible combinations of edges, so its complement is going to be the graph with vertices A, B, and C, and no edges. Consider that graph G has now vertices A, B, C, D, and E, and edges AB, BC, CE, and CD. Let's find the edges in the complement. A is connected to B, but it's not connected to C, D, and E. Edges AC, AD, and AE are missing. Node B is connected only with A and C, so the edges in the complement are BD and BE. The only edge that is missing now is between nodes E and D. The complement of graph G has vertices A, B, C, D, E, and edges AC, AD, AE, BD, BE, and ED. Are you curious about graph theory? I have a new playlist that may be of your interest. I recorded multiple videos explaining the main concepts, problems, and theorems of graph theory. I will leave the link to the playlist in the description, and I'll be waiting for you in the next video.